So for our agenda today, we will start off with an introduction to SuperAnnotate, and then we'll move into an introduction on the COCO dataset, which we used for this project. We'll then discuss the mass CRNN model, followed by a deep dive into the process we implemented for our project, and we'll end with a review of the results in our Q&A section. Before we dive into our topic today, I do want to share a little bit more about us here at SuperAnnotate. So SuperAnnotate was founded in 2018 by Tigran and Vahan Petrosian, our CEO and CTO. We raised $14.5 million in Series A funding last year, and we brought our total up to $20 million with further investments. We have a global team of over 150 ML enthusiasts, and we're proud to say that we're a top-ranked platform in the data labeling category on G2, and we also received a high performers badge from them as well. So this slide here is our offering summary, and our offering is split into 3 categories that, when combined, form a powerful, robust, and efficient suite for all your annotation needs, as shown in the slide here. And we're briefly going to dive into each of these. So first up is our annotation platform. So here you can automate labeling, get unparalleled control of your annotation workflow, quickly spot quality issues in your data, and seamlessly integrate into your existing pipeline. Next is our data ops services. So we've screened over 350 annotation service companies around the world and selected the top 35 to be in our marketplace. Our handpicked teams of professionals are all trained on our software so that they can flawlessly leverage the platform's features. Lastly, tying the 2 options together is our MLOps success program. So our DevOps and ML expertise really sets us apart from our competitors. We serve as an extension to your data teams, and we're not only supporting your efforts labeling data sets, but also setting up and improving your data pipelines. Our dedicated account teams include ML engineers, annotation experts, DevOps engineers, and project managers. So from day one, we're able to provide a white glove service, bringing our best practices to help you scale your data practice. So now that we have a good understanding of today's topic, of SuperAnnotate, let's dive into today's topic. So before we can really get into the project that we executed that we'll be talking about today, I think it's important that we first discuss what data-centric AI is. So data-centric AI puts the focus on high quality data for training models rather than the models themselves. So the goals will be to make labeling consistent, remove ambiguous data samples, and then flush out any noisy data. The data-centric thinking approach puts emphasis on data being evaluated at each level rather than one event at a time. So usually with model-centric thinking, we're only evaluating our data after training. And this can hinder workflows and block engineers from really leveraging the full potential of their data. Whereas with the data-centric approach, we're focusing on the data and then continuously evaluating the quality of our data over time. And so 2 main benefits of this are greater model performance and then less data to achieve high performance. So as you can see in this diagram, the evaluation of the data takes place throughout the ML lifecycle rather than just after the training is done. And so by doing this, we can improve our data and in turn improve our ML model. So now that we have a clear understanding of what the data-centric approach is, let's explore the data set. So for our project today, we've used the COCO data set. And for many of you, this might not be a new data set, but in case it is, I do want to go into a little bit detail here. So what is COCO? So COCO stands for Common Objects in Context. And this data set is a large-scale object detection, segmentation, key point detection, and captioning data set. So you can see here that it has annotated data for pretty much all of your CV needs. And for the purpose of today, we're going to be focusing on segmentation and the 2017 data set, which includes 123,287 images and 886,284 instances. So a lot of data there, and this is just one of the data sets available. If you go to the COCO data sets, they have various options there, but the 2017 is one of the more recent. And the COCO dataset really aims to address 3 core research problems in scene understanding. So we have detecting non-iconic view perspectives of objects, contextual reasoning between objects, and the precise 2D localization of the objects. So for this reason, it's one of the most commonly used and accepted data sets for computer vision. It's often common practice for engineers to use the COCO dataset to pre-train models for CV tasks. And then they'll use those same weights as a starting point to train with the other data sets. And for this project, we decided to use the stuff segmentation dataset. That is the name of it, but that just includes the images and the polygons for those masks. Now, here is the initial data distribution for the 2017 data set. As you can see here, our data set is not balanced, which is something that is always important to consider. And it is important to also consider that the issues that an imbalanced data set can cause. And so for our project, we did not aim to address any of these problems, but I do want to point out that you may want to handle imbalanced classes using either hard, random, or IIU-based sampling in a production setting. Now that we've reviewed our approach and the data, I'd like to go over the model architecture we used in this project, which is called the MassCRN model. And so the MassCRN model is a state-of-the-art convolutional neural network for image segmentation. It detects objects in an image and generates a high-quality segmentation mask for each instance. MassCRN was developed on top of faster RCNN, which is a region-based convolutional neural network. And so for the mass RCNN, it has an additional output column. So the output would include the class label, the bounding box offset for that region of interest, and then the mask as well. So it generates a binary mask for each region of interest in parallel to predicting the class and the box offset, which is what makes it unique compared to faster RCNN, which would use the prediction to just do the region. And this image here really illustrates the process that's going on. So the model takes our input image, detects the ROI, and then assigns a class and generates the mask. Well, it's shown here that this is happening in 2 steps, and in actuality, it's really happening in parallel, which makes this model super powerful. All right, so process overview. So I already talked about that we're taking the data-centric approach and that we've used our COCO dataset. And now we're just going to walk through the steps that actually took place. So first step was to use our MassCRN to train on the original COCO annotation. So we just downloaded the data from the COCO repository. We use that to train our model. And from that, we are able to filter out the low scored items to be re-annotated, which we put back onto our platform. So I do want to point out that SuperAnnotate allows you to upload this information, which makes it really easy to query and filter right inside our tool set. And then we cleaned all incorrect or risky annotations on our platform, leveraging our vector editor and explore tool. So our explore tool really allows you to have full control over your data set. As I mentioned, you can query and filter items there, and it makes it really easy also to spot check and QA your data as well. And then our vector editor, of course, makes it easy to adjust those annotations. So we don't need to annotate from scratch. We were able to take the annotations that were provided and clean them up. And in the cases where they were incorrect, we were able to fix them. We then took that clean data set and we retrained a new model and applied the predictions on the unlabeled data set included in COCO. So with that 2017 data set, there is a set of train, test, and val, but also some unlabeled data that you can use to test to see how well your model is really doing. And so the final model was retrained with those new labels, and we were able to see an average of 6% higher map score, which we're going to dive into a little bit deeper. So looking at model accuracy is of course important, and it's probably the most common way to evaluate how something is working. But because we're really talking about a data-centric approach, I did want to take a second to highlight the visual difference between the original annotations and the corrected annotations. So on this slide here, we have an original annotation from the COCO dataset. So this was just directly imported from the repository into our platform. So you can see here, it's nice to be able to visualize the data. And just looking at this image, you can definitely see that there was room for improvement. So as I mentioned earlier, we took those low scored images and we put them on our SuperAnnotate platform, where we can easily leverage our tool set and those smart features that we have to clean this up. Now, if I click here on the right, we'll show the corrected image. So it's easy to see just from visually examining these images that there's a vast difference in annotation quality. And it's just as easy to imagine the modeling effects of having this higher quality data, but luckily we don't just have to imagine because we put it to test. So this table here shows the mask average precision for the model using different annotations. With the original data set, we achieved a map of 40.8. So not terrible, but the real impact is seen when we show the results with the re-annotated data. So you can see that 46.1, so just about 5-6% increase there. So just after one iteration of filtering and re-annotating our data, we were able to see this 6% increase in our model's performance, which is pretty impressive. And our experiment only aimed to address low quality annotations, which is one way to use the data-centric approach, but you could always do further cleaning, balancing, and sampling, even compare between different models to really see the impact of just changing the data source. All right, so the last tasks that we will go over today are the takeaways. So taking a data-centric approach can save time and the resources while still yielding model performance. So rather than needing a lot of engineering hours or a lot of data, with this data-centric approach, you can spend time really fine-tuning the data, making sure that you have high quality data and thus using less data to achieve high model performance. And the last two really focus on the downsides of focusing on your model rather than data. So traditional model-centric approaches heavily rely on developers, which results in delays to optimize performance and support AI models. And then those workflows can also be a nightmare. When you have different teams with different methods to manage your data can quickly become messy. It's hard to keep track of what high quality data is, and just overall is a lot messier than having someone like SuperAnnotate take control of your annotation to ensure that you have high quality data. So I know we just covered a lot and we wanted this to be, an interactive session. So I'd love to yield some Q&As. So pop in your questions here. Right off the bat, I see one that says, will we receive this presentation? Absolutely. We will send this out with a follow-up. Another question is just more about the difference between the model-centric approach and data-centric approach. And as I touched on the first slide up here, let me go back. We're really putting the emphasis on our data. So rather than changing the hyperparameters of our model, doing a lot of work on the model architecture, changing that, we're going to put a focus solely on the data. So in computer vision, that's going to really tie into the annotations. So we're going to make sure that we have a consistent labeling instructions. We're going to make sure that there are no ambiguous or as little ambiguous data samples as possible. And any noisy data, we really want to remove that from our sample. It also might be in terms of the balancing of the data set, like we talked about earlier, where our classes are quite unbalanced. We could take a random sample or a hard sampling to really get those data sets balanced, and that could potentially yield to higher improvement. And so those are going to be the main differences there. Another question just came through on how does the polygon annotation bring in new accurate input? So the polygons are converted to mass, which are then compared to the mass that's output and used to train on the mass CRN. And so when we're drawing the polygons, those are then converted to the mass. So those are the annotations that we're using to train the model. So you can think of this as just higher quality training data. So that's how it's really bringing in the more accurate model performance. Next one. So it's asked, this next question is asking whether we are doing the annotations manually or if we're using any image processor. And on our platform, you can leverage both. You can do both manual corrections, or we do have some pre-trained models that you could leverage. You could use either iterate over them with some manually labeled data to improve their accuracy and draw the polygons that way, or again, manual annotation works well. We usually like to do a hybrid approach when trying to obtain super high quality data. So it always is a good idea to start with some manual annotations and then perhaps use a model from there to do the annotations. Yeah, so this is a great question on advice on discovering systematic training data issues like lighting condition, weather, or object or position. Using our data curation platform, it's really easy to spot issues like this and being able to create a subset of data where these issues might be. You can also identify these and attach a score on our platform. I think the best way is to leverage a data management platform like SuperAnnotate, or perhaps some active learning algorithms where you can see where those conditions are that your model is struggling with most. Let's see, lots of great questions in here. So best practices for mitigating the problems for imbalanced classes. So does Mass RCNN account for this? So there is some level of accounting for imbalanced classes with the model, but I think one of the best practices is doing resampling. So that is going to be the agreed upon best practice when it comes to imbalanced classes. So again, there's a few different approaches you can take. A random sample would just be trying to get a random number of n from each of your classes to use for training. You can also do more of a hard sampling where you're going to select them, and then you can also look at things like IOU to do your sampling. So there's a lot of different ways that you can mitigate the problems that are associated with them. And there are some modeling choices that you can make as well, but with the data-centric approach, we want to take the stance that we're going to handle this before the data is used for training. So one is about how to improve the quality of annotation. So yeah, that is a good one. And I would say having a good tool is definitely up there with how to improve the quality of annotations. And that's not only in how you label the tools available for labeling, but also the data management side of things. So it's all well and good to have a tool that you are happy with the quality, but if you can't really get insights into your data and be able to visualize and curate these data sets, it's hard for the full impact to be seen. So I definitely think a tool that allows you both the ability to draw or predict high quality annotations and then curate them as well. Someone asked if we use customer data to retrain our models, and I just want to make that super clear that we do not take any of our customers' data to do the retraining of our models. All the models that are on our platform are trained with Cocoa. So as we discussed, it's common practice to use that as kind of a baseline and use those weights to then train with other data. So on our platform, if you're utilizing our neural network section, you're going to be putting in your own data. We do not store any of that information. It's just in that one instance of the model that you have in your environment. Another one here is on whether or not this data-centric approach can be applied to, other types of machine learning. And the answer to that is absolutely. So with computer vision, we obviously require labels, so this is a supervised approach. So in terms of redoing the annotations, it's going to be focused on supervised machine learning, but you can always take the data-centric approach no matter what type of machine learning that you're doing. The goal, again, is to focus on your data. So rather than looking at different model architectures, we're just going to focus on the data. So that could be as simple as making sure you have clean data, making sure there's no missing data. All of that is a data-centric approach. And that is just, again, the whole point is to switch the focus. So it can absolutely be applied to any type of machine learning. I'll do a last call for some questions. I don't see many floating in here. A lot of excellent questions coming through. All right. Well, I don't see any further questions. Oh, here's one. Yeah, so this question is, what kind of applications can we use the Cocoa dataset trained model? And so this specifically is asking about medical applications. So as we talked about here on this slide here, the Cocoa dataset has, object detection, segmentation, key point detection, and capturing datasets. So there's a lot of applications that you can use this for just doing, using it as a base, you can absolutely use those weights to perform on predictions on medical images. So again, it's just going to help with a baseline for you to start with. And then as you train with a set of your own high quality data, you'll get a new set of weights, which will be your new baseline. And then you can kind of iterate through that process and continue to improve by improving the data that you are using. Awesome. Yeah, well, this is a super exciting webinar. At SuperAnnotate, we really do take the data-centric approach. We believe that investing in your data set is going to ultimately lead to a higher payoff in terms of your model. And so it's interesting to investigate like commonly used data set like COCO and just analyze the annotations, re-annotate, and see the payoff when retraining the model. And so I appreciate you all joining. And I'll stick around for any further questions.